Hello everyone. Today we will discuss about the inductive reactance, capacitive reactance and their variation with the frequency. So what is inductive reactance? While deriving the phase relationship between the voltage and current, we had derived that the maximum value or the peak value of the current is E naught upon omega L. So if we compare it with this, what do we get? We get that omega L is equivalent. I am not using the word this equal to, I am using equivalent to resistance here. So this quantity omega L must behave in the same way as the resistor does. So what is resistance? It is the opposition to the current, right, by a conductor. So this is the opposition to the current when AC is applied to an inductor. So omega L, this quantity is called as inductive reactance, and this is the opposition offered by an inductor to the flow of current through it. So it behaves in the same way as the resistor behaves. So XL is omega L, and this can also be written as 2 pi nu into L. So nu is the frequency. For DC, that is direct current, frequency is 0. So therefore XL is 0, right? So that means inductor freely allows DC to pass through it because the opposition is 0. So therefore inductor offers 0 opposition to direct current. So therefore it allows DC, right? Also you can see here that XL is directly proportional to omega, or XL is directly proportional to the frequency. So if I want to plot the graph of variation of XL with omega or frequency, it will be a direct proportionality graph, right? And also since it behaves like a resistance, so its unit will also be ohm. So I can write down the SI unit of XL, that is inductive reactance, is ohm. Okay. Similarly, we are going to discuss the capacitive reactance here. This capacitive reactance is represented by XC, and if you remember, while deriving the phase relationship between the voltage and the current, we had derived that I naught is equal to E naught omega C. So if I compare it, I can write it like this also, na? And then compare with I is equal to V upon R. So if I compare these two quantities, we see that this is comparable to the resistance, right? So I can write that here R is equivalent to 1 by omega C. So 1 by omega C behaves in the same way as the resistor behaves. So you can write down here that here this 1 by omega C can be written as XC, which is actually capacitive reactance, right? And we can define it now the same way as we had defined inductive reactance. So here it is capacitive reactance. Capacitive reactance is the opposition offered by a capacitor to the flow of current through it, right? And we have already written that XC is 1 by omega C. So this can also be written as 1 by 2 pi nu C, right? So for DC, how much is the frequency we had written? For DC, frequency is 0. So XC is 1 by 0, that is infinity. So that means XC or capacitor offers infinite opposition to DC. Therefore, it blocks DC. This means it blocks DC. Now, if I want to plot a graph between the capacitive reactance and the frequency, this is an inverse relation. So this will be same shape. Right? So this was all about inductive reactance and capacitance. Hope you understood it. That's all for now. Have a great day.